Okay, folks, we are now going to start on a new project. Got this one from Marketplace from a guy for about 40 bucks. And said he was listening to it one day for a few hours and it sounded weird. Came back to it and it was sparking. So he shut it off. Later he turned it back on and had no audio, I think, out of one channel. So have a look at it. It is a Quadraflex. Not good with the camera yet. Let's see here. 300R. Yeah. See if we can get ourselves positioned here. Let's take the screws out of this thing. See what we got in here. Okay. We got some regular Phillips. Yep. And what we'll do, bag these as we go. Find an empty bag. Sure. Don't want to lose our parts. Stash that in here. This is, if I didn't say it already, the Quadraflex 300R. Quadraflex 300R. I think was unit produced by Pacific Stereo. House brand. Don't know what that was. Oh, what do we got? Oh, just a piece of plastic there. Trim ring. Actually, we may take that out. It'll come out. It just came out. I put it back in. What about that one? Yeah, we'll leave those in there for now, because they don't want to come out. Turn it around. Get these screws out. So my guess is what we got is probably blown output transistor. We'll find out here in a moment. Surprised it didn't take any fuses with it. Come on. Alright, I want to get those rings out. I don't like leaving them in there. I know what's going to happen. I'll set this thing aside and they will fall out. And I'll lose them and never be able to find them. And that is the family cat, Kiwi, named by my children. You want it out, huh? Yeah, I hear you. Alright, let her out here first and then continue on with this. 1 second. Okay. Now, time for the big reveal. What's going on? Does this just lift off? Am I missing a screw? Oh, got more in the back. Yep. 3 more. Let's get you guys first. Never worked on one of these, by the way. I have a few Quadraflexes, not this model. I have two of the same model. That number is 666. A friend at work says that some guy from the 80s, some rocker, is going to come out of it and kill me one day. Hadn't happened yet. Now, let's strip that. Let's grab a different screwdriver. Come on. There we go. Better. All right, let's hide these away in the proper bag. There we go. Turn it around again. Okay. See what we have. Set that aside. There we go. Okay. Well, you saw sparks. Oh, wait. I think I see where. Oh, yeah. We got some burnt resistors, some charring. Don't know if that's caused by an output transistor or a driver. Let's look at the rest of this thing here real quick. Build quality looks all right. Separate PCBs for pretty much everything. Brand of caps we have. Doesn't look like upside down. We got some Elnas. Good. The heck brand is this? Yeah, we'll get to that in a minute. Oh, more Elna. Alright. Let's take some measurements. Grab our meter and we'll do a diode test with output transistors. I believe it's the left channel that has kicked the bucket here. Alright. And we want diode mode. Let's see what we got here. I do not know what these transistors are yet. Cannot see. No, that's shorted. Not looking good there. I don't like the way they mounted these. They just bent the leads over. Is this? No, this ain't stock. Somebody has been here. Yep. Somebody has been here. Replace these guys. What are we measuring here? Let's get this stuff out of the way. Alright, try again. Oh yeah, that one's shorted. Okay. So, I'll have to get in some better light here. Maybe I can show you what I'm talking about as far as these shorted transistors, or at least the burns here anyway. See if we can unmount you here real quick. All right, Can you see down here? Look at all that burnt, crispy goodness. Okay. Bear with me here. I think I'm going to try and get this in a different position, maybe upright so I can see it better. Perhaps see if there's a schematic online, and then figure out where to go from there. Probably going to have to rebuild that board. Several transistors will have to be replaced, is my guess. I'll measure the rest of them, figure out which ones these output transistors are, find out what the originals were on the right channel. Maybe I have something similar that'll work. I'm kind of curious as to why this happened again, because these are obviously not originals, and they are, well, they gone. We'll be back real quick. I got a few updates. So, let's see if I can get you in here so that you can see what I'm looking at. Don't really know how I'm going to do this. Alright, so these two guys right here look to be the outputs for the left channel. And these two guys are outputs for the right channel. Now you'll notice that something is not like the other. These are soldered into the board. These are not. You can see they're what I call, or I've heard called, dead bug style. They're upside down, which dead bug style probably wouldn't be mounted to anything, but they're upside down. The leads are mounted to wires instead of into the PCB. And reason being that they're mounted this way, upside down, and with two wires directly. And I might also add two wires of different varying wire gauges, so not even the same size wire. But it's because they have pulled pads and damaged traces. I think we can fix this in a much better way. We'll have to dig deeper. Primarily that driver board right there, and see which one of those transistors are shorted, which ones aren't, other components as well. So I get back to you as I have more updates. So what we're going to do here, we're going to try and get a look at the bottom of this board to see if those burns actually go through the board or not, see what I'm actually getting into. I'll move this bottom cover here first. And we got a few screws, more than before. Get a driver here. And one of which hits the floor. Gotcha. Go to our baggie here. Put these in here before we lose them. Okay. I do like that this one has driver board exposed after you move the bottom cover. Oh yeah, well, the bottom of the board is darkened. I don't know if you can see this right here. Not really burned all the way through. I think we have something that we can work with. Okay, well, meter shutting off. We'll get back to it. I'll keep you updated. Okay, got some more updates here. Pulled the transistors out, and not sure why they were wired in the way they were. They were upside down because I know they broke the traces. But they soldered on some extra wires so that they could then make connection. They could have just unsoldered the wires from these pins to begin with and soldered them to the leads on the transistor. But they also changed the polarity of these two wires on this one and not that one. But these are the same transistors as those. They're just replacements. They're the same part number. I don't know. Weird. Anyway, before you guys roast me, yes, I have one of these cheap $10 transistor component testers, whatever. I know they're not 100% accurate, but hey, they do work sometimes. They will show me some good info. So this one is I believe the, what is it? D613, I think. This would be the NPN, because these are complementary push-pull amplifier. Yeah, NPN, that one's good. Showing me gain to 72, which is probably inaccurate, but you know, hey, showing an NPN transistor and looks good. Now, this is the B633, I think, which would be the PNP. And this one shows up as two diodes, which in the simplest respects, a transistor can be looked at as two diodes. NPN not pointing in, PNP pointing in, please. That's a way to remember whether you got an NPN or a PNP. You look at the diodes, the arrows. Show you again here because they look like arrows. So pin 1, that would be your junction between the two, and this is a PNP, so pointing in, please. So they're pointing into the junction from pins 2 and pin 3 into the junction. NPN be the opposite, not pointing in. So, all right, well, guess I'm gonna have to find. I know I don't have those transistors. I'm gonna have to find some that are comparable, and then we'll have to dive deeper into the driver board and see if we can figure out what's going on there, because something in there most likely shorted, or could have been vice versa. This one could have shorted and then caused those to go out, but either way, there's some shorted in there, and there's probably some resistors burnt up as well. And gonna have to figure out what all those are. Still got to look up the schematic for this as well. Haven't done that yet. I get excited and like to dig into the actual part first, or the device center test first, before I actually look up things like that. So I'll get back to you. All right, so it's been a couple of days. I've slept since last time I worked on this. Went ahead and changed out the drivers for the amp board, and they didn't match. They weren't complementary. One was NPN, one was PNP, but they were not within the same family, I guess, if you will. And one of them I couldn't get to measure while it was on the board. Let's see if I can get it out of this bag here. And that was because it was one of the ones that had, like the resistors on the board, it had burnt up, and the leg actually fell out of it. I don't know if you can see that. See if we can zoom in some, or at least get close enough. So that's why it didn't measure. So I replaced it. Now, like I said, it didn't match. This was the, I believe, the NPN. It didn't match the PNP one that was in here. So apparently this has happened before, and when it did, they didn't match the transistors. They just found an NPN that would work and stuck it in there. Did that cause the problem that we're looking at now? Maybe. I don't know. Anyway, I went ahead and replaced both of them. And I also replaced those resistors. Now, I'm colorblind, so reading resistor values on the actual resistors themselves is hard for me to do because there's color bands. So what I did is I just went on the other channel because I don't have a schematic. I went online, couldn't find a schematic for it. I went on the other channel, found the two same resistors, pulled them and measured them, found out one's 4.7 ohms and the other one's 100 ohms. So I had those, put them in. That's good. As far as the transistors go on the driver board, I didn't have the ones, obviously the ones that were in there aren't made anymore. They are, let's see, two SD 438 and two SB 560. So I still have the matching pair in the, or the complementary pair, excuse me, on the right channel. The left channel, I don't have, I didn't have what I wanted to use. I wanted to try and match up, of course, like you do every time you replace a transistor. You look at certain values or certain characteristics, depending on where they are in a circuit, and try to match those up. So I went with closest thing that I had, which is a BD 139 and a BD 140. Those are rated up to 80 volts on the collector, and the highest voltage I measured in here I think was 30 on the collector on the ones that are already on here on the right hand side or the right channel. So those should be fine, and they're pretty close I think in gain. It might be a little bit higher, but they should work. I have also gone ahead and recapped this driver board, and I did that because I thought, this has happened a second time. I want to try and prevent it from happening again. And some of the caps that were in there, most of them were okay. They're a weird brand that I've never seen before. Nerta or Nita, N-I something T-A. Most of those were good. Surprisingly, the ones that were bad, there was a couple. And when I say bad, I don't mean bad like extremely leaky or shorted or open or whatever. They had drifted in value. They were beyond 20%, either above or below. So I replaced all those capacitors on this board, and I didn't go crazy with the type of capacitor. They're mostly just Worth brand, which is a German, if I'm not mistaken, owned company, and I've had good luck with them, and they're cheap. And I also had a few Chemits, and I believe that's all. Let's see, Worth, Chemet, and maybe there's a couple of bipolar or non-polarized capacitors. I don't remember what brand they were. I think they were Nichicon, if I'm thinking correctly. But those should all work out okay. Most of them had low enough ESR, and we're not very leaky. So it looks like we're going to be okay as far as capacitance goes. I'll probably end up recapping the whole thing once I get it actually working. I have powered it up on the dim bulb. Let's see if I can show you. I've got it plugged into the dim bulb. Dim bulb's plugged into my Variac, which I have a meter on it, so I can see digital meter. It's out of camera, I think, at the moment now. But anyway, we'll flip the power on. The light barely comes on and goes, dim. I'm at 120 volts, and I'm only drawing 0.3 amps. This thing is rated, I think, at 30 watts, if I remember correctly. And obviously, it's not doing anything right now as far as putting any wattage to any speakers. There's no load. I'm actually still have the driver or the output transistors. Can't talk. Actually, still have the output transistors removed on the left channel. I haven't replaced those yet. I did swap the wires back the way they should, and the way they should be. And I think I have some transistors that are going to work. They're not exactly the ones that I wanted to use, but it's what I had. And they are, let's see, 8 amp, 150 volt, 50 watt. The NPN is the MJE15030G, and the PNP is the MJE15031G. So the 30 and the 31. So those are, complementary to each other. So I'll eventually pop those in there and probably get that done hopefully within the next couple of days. And we'll see what happens. But yeah, so far, still drawing 0.3 amps. It's not complaining. The dial lights all look like they're working, so that's good. I haven't checked any voltages at the one output on the right channel. Obviously can't do it on the left. There won't be anything there. There's no transistors there yet. But we'll get those in and we'll see how things go. Catch up later. All right, so it has been some time. As you can see, some things have been done here. It's actually probably been about 2 weeks since we last did any recording. A lot of things going on. Anyway, this works. So I had to get the two transistors, the output transistors installed, which you can see back here. And let me tell you, that was kind of a pain. Main reason being is that the way they have these in here, you notice on the two originals that are still in, they didn't use anything to actually mount them to the heatsink other than the stickiness of the thermal, which at least on this channel, it's worked all this time. But when I installed these over here, I couldn't get them to actually stay in place. They would hang out just a little bit and there'd be a gap, and they would run probably 10 degrees hotter than the ones on the right channel. So the smart thing to do, and probably the easiest thing to do, which I'm not known to do the easiest thing all the time, would be to actually use the mounting tab that's on all these transistors to start with, and actually drill a hole into the heatsink and use an insulated washer and a screw and a nut on the backside, hold these in tightly against the heatsink. Problem is there's not a lot of space in here. I've got, a drill, but it's, not a nice right angle drill. What I'd be able to get in here nice and easy. So with the actual drill bit on there, I'd probably be out to here banging into everything, trying to get these holes drilled. And of course, you want to get them nice and straight and so on. So instead, what I did is I took some metal clips, and I think I may have, yeah. So these, let me get a hold of one. There's a couple in this bag. Are actually clips. If you can see those. These are clips to hold in much larger transistors. And the way that they work is you would have a heat sink behind here, a slot here, and a slot there, transistor in the middle, and these fingers, whatever the hell you want to call them, would actually slide into those slots and lock in, holding the transistor tightly in place. Well, obviously there's no slots on these. They're different size transistors, but I just lobbed off the side of these, drilled some holes, and using the screws that were already there, held the transistors down that way. And so far it seems to work. They're about the same temperature as the other ones when they're running, maybe a degree off, either hotter or lower, but nothing to be concerned about. I've also gone through and done a recap on most of the unit. I'm not done with it yet, but there's a tone board under here, and I forget what the other board is down here as well. They're actually on the bottom. I need to get those done, which I have to end up pulling the faceplate off in these knobs in order to get to them, because they're so tucked in here so nicely that there's no way to get my hands down in here to actually put in the cap once I've taken it out from the back. So what I want to show you now is actually this thing working, since I've got those transistors replaced. And let's see if we can do that now. So we'll just turn on, not going to run it through the dim bulb because I've already done that and I know it works. So I just got a variac and I've got it set to about 120, and I can see what the current and power and everything is on here. And I've got it plugged right in, as you can see. And so we'll just turn it on and see what it does. Lights come on, drawing about 0.39 amps. Voltage is set to 119. It varies a little bit from day to day. We'll see if we can tune in a station. Volume's all the way down. And oh, we're on tape. That's one thing. This thing has 3 tapes inputs instead of an auxiliary. The third tape is basically just an auxiliary. So we'll put it on FM. And probably can't play it for long because, you know, copyright. So we'll get a station in there. So you see we have audio. Let's see what else we can get. And of course, I don't want to get copyright strikes, but let me see if we can find something that's just talking. Oh, there's a commercial. WOVO Auburn Bowling Green. Balance, you got left and right. Treble. 96.7 and 95.9, a 7 Mountains media station. Bass. Loudness. High filter. All right, turn that down because we don't want to get copyright. But as you can see, it works. And right now, because we're actually pulling in a station, we're at 0.43 amps. We go up a little bit. Classics from yesteryear. That's right. I like to say old and new, modern and traditional, and some in between too. Welcome in. We're streaming online. So as you can see, it works. Like I said, what we'll do next is I'll go in and I'll do the rest of the recap on it. As you can see, the controls, they're not scratchy, they're not creating any static. Normally I would go through and I would deox it or contact cleaner, whatever, all of these. Everything seems to be fine. They're all working well. And rather than going and disturb everything, I think I'll just leave that as is. As far as the caps go, ones I have done so far, there have been a few that were pretty off in value. Let's see what this one is. This is a 1 microfarad, 50 volt, and I think these were like ended up measuring 1.5. So let's see what we get. Yeah, 1,543 nanofarads. ESR is 5.6, and it's kind of lossy too at 3%. I don't know if y'all can see that. There you go. Let's try another one. Let's try one of these black ones here. This off weird name brand. I think there were some 0.47s. That's what this one is. And I think they were pretty bad as well. About 20% is the limit, plus or minus, you know. And this one's at, yeah, it should be 0.47 or 470 nanofarads at 720. 8.3 ESR and 2.7% leaky. So, yep, that was not good either. So, even though everything worked with all these in there, it's only a matter of time before these caps turn themselves into resistors, and then you have a short or something else, and the receiver no longer works. So, we'll start there. We'll turn it off first, unplug it, and these knobs just pull off. So I'll start taking them off. And if I have my bag, where is it? These are all the caps I've already taken out. I think this was the one. Yeah, Quadraflex 300. And I'll just throw them in here. Usually what I do is I clean these too. I'll use soap and water, or you can use like Mr. Clean and water in a little Tupperware dish and just soak them and then take a toothbrush to them. And that usually takes care of them. That one, base, does not want to come off just yet. Let's try. There we go. Okay. And those pulled off. Boy, those come off really. All right. It looks like we got maybe 3-4 screws on top, probably a couple on the bottom. And I should be able to get to the underside here. I'll lift it and show you. Here's our underside here. I just realized I don't have my light on. Let's see if we can do that real quick. There, how's that? Probably see that a little bit better. All right, good enough anyway. So this is the tone board that needs recapping. There's a few decent sized caps on there. Or no, excuse me, that's a balance and volume control board. This is the tone board. I had that backwards earlier. This is a switch board here. Just basically has the switches for your tape inputs. I don't think I need to mess with it. Like I said, everything on there is moving nice and smoothly, no static or anything. So not going to mess with it. But the tone and volume slash balance boards, I will do a recap on those. So I'll do that and get back to you. All right, guys. Well, I think this thing is done. What we're going to do today is do a little power test and see what the output is on this thing. I've finished the recap. Um, everything seems good. I listened to it for a few days. Um, I'll show you our setup, how we're going to measure, and I think we'll be pleasantly surprised. I think it's supposed to be about 30 watts, and it looks to be actually doing that or maybe a little better. So let me see if I can switch the camera around. So here is our setup. We have the receiver connected, and we're connected on, as far as the output goes, to a couple of 8 ohm 100 watt resistors. Um, there's a Bluetooth receiver that's hooked up, but I'm not actually listening to that. What we are listening to is a 1 kilohertz sine wave at about half a volt on both channels. You could go higher or lower. I just chose half a volt. We also are looking at the signal on our cheap little oscilloscope. Both actually left and right channel track pretty well, and we're going to do the math here. I'll turn up the volume and we'll see what it gets to. I've already looked at it myself, so I kind of know what it's going to look like. But if we increase the volume, we should get to, let's see here. We're looking at the RMS voltage here, and we can get to 16. We can actually get a little bit higher, but I feel safe at about 16 because we're quite up high on the voltage, or on the volume here. We're past 3/4 of the way. So if we look at, let's go down a little bit. We're almost at 17 there. So about 16 volts, we'll say safely on the output there. And what that equates to, as far as wattage wise, if I remember correctly here when I did the calculation a minute ago, was about 32 watts per channel, which this thing is rated at 30. And so we weren't clipping, and it didn't go into protection, and we were still going higher in our output. So like I said, I think this thing is done. We'll move on to the next project here soon, hopefully. I got to find out what's next in line. I'll put this one back together, work it, take it to work, and have it listen for maybe a couple of months, see how I like it. Maybe it'll stay longer, we'll see. And then we'll move on to the next one. Want to try and get videos out here, I don't know, every couple of weeks, maybe once a month. Just depends on how busy we are. This time it was several weeks before we actually got this thing done. But see what happens in the future. And hope you like, comment, subscribe, and come around and watch the next one. Have a good one.